All right, I want to welcome you to section 2.2. We've got some measures of spread to talk about here, and the first one is range. And the range is really just how spread apart the data is. So you just take the largest value and subtract the smallest value. One thing, we have a casual version of range. We don't want to say, hey, the values go from 5 to 75. We want to take 75 minus 5 and say the range is 70. So just be a little bit careful of that, since we have kind of like a normal working definition of range. But then in statistics, we're interested in the mathematical version of the range. And this is similar to how you start finding your class widths, right? You figure out how wide your data set is. So that's the first step there. Then we have the interquartile range. So it's abbreviated to IQR. And this just tells us where the middle 50% of our data is. And we've worked with quartiles before, so we do quartile 3 minus quartile 1, and it is that value there. Again, the range and the interquartile range are values. Then we get to the standard deviation, where things get a little bit crazy. The standard deviation is sort of just that average distance about how far each point is away from the mean. Some things to note here when it comes to vocab stuff. The population, I think I did the same thing last time. The population value here is sigma. So that's the standard deviation of the population. And then we use S for the standard deviation of a sample. And we get this crazy formula here. The standard deviation of the sample is equal to the square root of the sum of x minus x bar. So I call these values here the deviations, and we square those. We divide by n minus 1. Again, n is our sample size. And then we take the square root of all that. There is a similar definition for the population standard deviation, and I'll try to write it here, or not, maybe. Why do we not love it? Okay. So sigma, that's my best effort at a sigma here. And it's the sum of all the data points minus the mean. Notice we just switch to population values here, and then we divide by n instead of n minus 1. So really similar, just a little bit different. And then the variance is actually the value of the standard deviation right before we take the square root. And it should be that value exactly. The abbreviations here, the way we notate it, for the sample variance is sigma squared, and the population variance, the sample variance is sigma squared, s squared. The population variance is sigma squared. And they're literally, if you were to square this value right here, we square this value, or we don't take the square root, right? Now there's a formula here for the standard deviation from a frequency distribution. We don't really use that very much, but it's kind of similar to how we'd find the mean from a frequency distribution. So we find the deviation, and then we square it, and we multiply it by the frequency, how many times it occurs, divide by n minus 1. And we could do a similar one for the population, but we wouldn't really do that with that many data points. So, examples now. Quickly ran through that. We're going to find the range of this list of numbers. So I'm going to copy it. I'm going to show you how to do the work in Excel. We're interested in finding the range. Paste here. I got my list. I want to make it into just one column. So I'll copy and paste here. And then if I'm interested in the range, I just need to sort this small to large. And the range is going to be 92, the largest value, minus the smallest value. And so if I kind of copy my work here, I get this, and it actually ends up being 92 minus 3 with the numbers there. So I can get my cursor out of the way. Zoom in a little bit so maybe you can see that a bit better. But the range there, pretty good. Just taking the largest value and subtracting the smallest value. You might be able to do this in your head. That's okay. Showing work is good too. So there's one of them. Another similar question here. We're looking to find the interquartile range, and so I'll just take this data set here. And there's not, well actually I'll snip it. Show you how that works, since I'm not going to be able to really interact with the data very well already. So I just hit the Windows Shift S to get a snip up, and I'll just put this one right here for the interquartile range. And the reason I did that is because lists don't really come over into Excel well, so I'm going to end up typing these values in anyway. So here we've got them now as a usable list. We've got 1, 2, 3, 4, 5, 6, 7, and here also 7, so that's good. I'm going to sort them small to large. We're finding the quartiles. Now, I did say already here we have n equals 7. And so for Q1, its position, I'm going to take 0.25 times the 7. And then I'd go to the second number in the list. So in this case, we count here to 27. Quartile 1 is 27. And I'll just that here, reading from the list. Quartile 3, it's where the 75% of the data is, so 0.75 times 7. Again, that's 5.25, so it's going to be the sixth number. A little bit more work. We had a list of 7 here. The sixth is right here. It's 45. So my quartiles have a little bit of work ahead of time. And then the interquartile range, oops, don't know what I did there, but it was not appreciated. So the interquartile range, again, we're going to take 45 minus 27, and that's 45 minus 27 if I show the work there, if I use the cells. Well, I was going to try to copy and paste, but didn't work so good. So there's our interquartile range. I think I said it was 27. Oh, what was 18? Got a high quality miss here. Short memory. See if I can get it right. Phew. Okay. What was this other one? 89. Try to demonstrate some teachable moments. Okay. So, for this next one, I think I'm going to start it as its own separate video because this can get pretty involved. So, I'm going to take a break here again. A quick run through the vocab for section 2.2 on the measures of spread, and a couple examples of using Excel to figure out the range, the interquartile range. And a lot of this is building off stuff that you have done previously, so it should be pretty good. So stay tuned for the next video on finding the standard deviation and the variance. Thanks.